Welcome to IMS. We're here demonstrating with a collaboration between NASA, Synopsys, Ansys, and Keysight, a solution for virtual prototyping RF links for the moon, leveraging broadband communication systems. In this case, we're demonstrating a 4G system composed of a base station and two mobile users using the 4G spectrum around 2200 megahertz. So what we're modeling here is the traverse of actually two different lunar vehicles which are mobile users, and we model the propagation and the antenna response in that scene progressively as the mobile users move around. That's a simulation solution that includes accurate structural models of what's on the moon, any vehicle or structure that you place on that surface so that we can assess accurately the scattering and the propagation effects, absorption, diffraction, all the things that happen. Now, once we've established a channel model over time, in collaboration now with Keysight, we take the data from the channel model and the mission and apply it to emulation. And I've got Bob Stevens here from Keysight to talk about emulating the channel and then connecting to the radios. Bob?
So what we're doing here now is this PropSim unit is actually playing the propagation model from the moon. NASA for the past 20 years has had an orbiter going around the moon getting LiDAR data, and we've worked with Synopsys here to take and actually generate channel ray tracing data that we can play in the PropSim here. And this PropSim then is connected to the phone and the base station SDR radios right over there, and so we're going back and forth at RF talking to those, and this spectrum on the spectrum analyzer here is showing you the downlink carrier that's being fed to those phones with post-channel, post-propagation. And this is what's happening here in terms of the propagation. There's a coarse grain and fine grain piece of the model that we're managing here with PropSim. And the reason for doing this is that when we go here, look to see for the NASA missions, when they land at different places on the moon, they can go look to see for the place we're at, what kind of resilience and reliability do we have in the communication link, and we can do rapid prototyping for missions in this way. Last thing I'll say real quick is that we're also using this other equipment here called WaveJudge that's sniffing the conversation between the phone and the base station to look at the radio physics and do more analytics to see how well it's really working.
Now, it will be important for the NASA lunar propagation team to be able to pipe numerous high-density video channels through the link, which will, of course, need to be transmitted back to Earth. So to prove this out, what we've got here is a demonstration of a pair of HD video links where, if I bring you over here, you can see a pair of links that are being transmitted through this emulated link. Now, if I stand over here against this backdrop, what you'll see, I'll get myself in the right place, you can see my image as has been transmitted from one of those mobile users to the base station back, and you can see the video actually decoded through the progressively changing channel because of the motion of the subscribers. And so there's a second video channel on the other screen, and we're actually carrying both of them through this 4G link at 2200. So it works, and it's a great way to virtually site test for deployment to the lunar surface environment.